Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to Part 5 and Text and Sentiment Analysis in R. The materials at the link below navigate to the word cloud section and it will look something like this. Word clouds can be a useful visualization to quickly view the most used words in a block of text. Now R has the word cloud function, which is part of the word cloud package, and this can be used to quickly generate these plots. Now to use it, we're first going to have to load up some packages that we'll use in this chapter. So that's the tidyverse and tidytext and Gutenberger to download the text we're going to be analysing, and then word cloud to actually generate the word clouds. So I'm going to go across to my RStudio. I'm going to create a new R Markdown notebook, just as we've done before in all of the previous chapters in this workshop. And I'm going to save this as word cloud. Again in the workshops folder. You of course can place yours wherever you would like in your computer. There we are. So we're going to first load up the packages that we need. So we need tidyverse, we need tidytext, again if I can type, we need Gutenberger, and now this new package is word cloud. Okay, I'll just load those into the notebook. Okay, now to create the word clouds, we first need to grab that tidy text version of our Adventure of Sherlock Holmes. So again, I'm going to load this up. So we're going to create a Sherlock Tibble, and this is going to be based on downloading the Adventures of Sherlock Holmes from Project Gutenberg using the Gutenberg download function. We're looking at text number 1661. We'll then do what we've done before, which is we'll pipe this through mutate because we do want the line number. So we'll say line number equals row number. Then we will also put this through unNest tokens, where we're going to basically create a new column called word by tokenizing the column text. And then finally, we're going to put this through an anti-join with the stop words to remove the stop words. And of course, we must remember to load those stop words up. So we can basically go data stop words to bring those in. And there we are, that's now joined together. Now what we want to do is now count up. Just bring this through. Now what we want to do is we need to count up the number of words. So then these counts can then be used to create the word cloud. So we're going to create a new tibble called Sherlock Counts. And this is going to be created from our Sherlock tibble, but passed through the count function. This counting the words, and of course we'll do what we've done before, we'll sort them as well. So this again produced a tibble which we've been using before in other parts of the workshop. Now the new part is we're going to be using the word cloud function. The word cloud function is really easy to use. All we need to do is pass in the column of words which are going to be appearing in the word cloud, and then also the column of their counts. So we can do this by calling the word cloud function. So the column of the words themselves, so that's going to be Sherlock counts, and then it's the words column, or the word column. And then the counts themselves, remember that's going to be in the n column, so that'll be Sherlock counts n column. Now we pass in some arguments to this function. One of them is we want to specify the minimum frequency of the word we wish to count. So we only want to basically plot the words that will appear at least a certain number of times. We do this, otherwise we'll just freeze R. And so in this case, we're going to just only show the words which have appeared at least 25 times by setting minfreq equals 25. And then the other thing is when it generates the word cloud, it will use a random number generator to basically randomize some of the positioning of the words, and that can make things look a bit prettier and make things a bit more dynamic. Because we're trying to go for a reproducible plot, what we're going to do is we're going to say random order equals false to try and make sure we get the same plot as much as possible every time we run this. There we are. So that's the plot. Again, it will be different. It's unfortunately we can't make this completely the same every time we run it. And again, if I run this a second time, it's come out the same this time, but when I run it, sometimes it comes out very, very different. And you can see this is the general word cloud for all of the popular words, the common words within the Adventures of Sherlock Holmes. And you can see Holmes is the biggest there in the middle. Now, we called the word cloud directly by specifying the columns like this. We can actually use the pipe and sort of pipe this through by using the with function in R. Now, what the with function will do is it will basically take a tibble and it will enable you to say, with a function like word cloud, specify the columns that you're going to be using from that tibble, and just makes a nicer kind of pipeline interface. So the way we do this, we would say Sherlock counts. We pipe this into the with function, and the with function will then basically say we want to use word cloud in the with function, where with the tibble that's being passed in, we're going to be using the word column, and then the n column for the counts and for the words which will be plotted, and then we can then pass in the other options, which are min freq equals 25 and random order equals false. So again, that's just another way of writing the same thing, but sort of puts it into this common pipelining kind of style that we've been using all the way through the rest of the workshop. There we are. We get the plot again. Okay, it's coming out almost the same. You can see we've got time here, and then we have door there, but it's the same size of words. Now we can also colour the words from highest frequency to lowest frequency by adding in a colour palette to this particular word. Adding a colour palette to this word cloud. So let's add a colour palette in. So again, I'm going to do a new block, and I'm going to use this piping syntax because I actually quite like it. I think it's quite a nice way of working with R. So again, we're going to use with word cloud, using the word column and the n column. We use the same minimum frequency of 25. We're going to use the same random order equals false. But now we're going to pass in a colour palette. And the colour palette is passed in using colours as an argument. And then the colours will be a palette which we're going to get from Brewer. And Brewer provides lots of different colour palettes for you. So we're going to do brewer.pal, and we're going to select a palette of 8 colours from the dark 2 palette. If I now run this, it's Brewer. I always misspell these things. There we are. It's now coloured it from the most common word all the way through back to the least used words. It kind of looks quite nice. Now we've used the dark 2 palette and we've generated 8 colours from that palette. We can actually view all of the available palettes available either by clicking on the link which is in the notes, or if you type display brewer.all, that will then generate all of the named palettes for you. So you can see they're not well separated using the font which is on my computer, but we can see we used the dark 2 palette, which you can just about make out is this palette here. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible colours that could be used. We could have used any of these other ones like set 3. So I change this one into set 3. Rerun. That would be using the set 3 palette. So okay, so that's taken us through most of this chunk of text. We now have reached the exercise, and the exercise is here, and that's basically draw a coloured word cloud of the words that appear in your chosen book. And so, have a go now, put me on pause, and when I come back from pause, I will do the same thing with my book. Okay, you've come back from pause now, and so I'm going to do the same thing with my book. So let's go back to RStudio. Again, I need to download my book itself. I'm going to use the Hound of the Baskervilles again. So this is going to be basically Gutenberg, download, and it's number 2852. And what I'm going to do is do exactly the same thing that I did at this point. So we had Gutenberg download. I'm just going to copy and paste this in to create a clean, sort of tied up book, because you don't want to watch me type all this again. And then once we've done that, we're now going to basically create the count. So again, we're going to copy and paste it from the counts. So in this case, I'm going to do this with hound counts rather than Sherlock counts, because this is now counting the Hound of the Baskervilles. Let's do hound counts will be from the hound tibble. And then finally, the last thing we're going to be doing is creating the word cloud from this. So we will take hound counts and we'll pass hound counts piped through the with function. So with word cloud, and we're going to then take the word column, the n column, min frequency is going to be 25, because I'll go with 25 as a starting point. Random order is false, and I'm going to use the same color palette that we used before because it kind of looked okay. So colors equals brewer.pal, choosing 8 colors from the dark 2 set. And now if we run this, or a bit of an error there. Interesting error in this point. Let's have a little look and see what hound counts looks like. So this isn't watching me debug something. I'm just going to not run this last part. So this is what word counts looks like here. Maybe we have too many words, but no, min freak is 25 will be at that point. Of course, I made an error at this point here. It's with the word count function where we need the round bracket there. Very common and easy mistake to make. And again, the error messages which come with R sometimes are not that helpful. So we're calling it with the word cloud function, where the word cloud function is working with word and min frequency and others. And then we just make sure we close this with 3 brackets there. Again, I expect everyone makes very similar mistakes when they're typing. Okay, so this is basically the most common words. And again, we have Sir Holmes, Henry Moore, Baskerville, as opposed to slightly different to Holmes, Matter, Time, Door, House, etc. Okay, so that's the exercise drawing the coloured word cloud of words. Let's now think about colouring different sentiments. So basically, instead of colouring the words by their count, let's look at different sentiments and making word clouds with different sentiments. So the first thing we're going to need to do if we're going to be looking at sentiments is obviously we need to load up the sentiments dictionary. So let's bring these in as we did before. Sentiments comes from the getSentiments function, and we'll use NRC again. And then of course we want to create the full sentiments tibble. So this will be Sherlock sentiments, which we'll create by taking the Sherlock tibble that we had before. And of course we're now going to do an inner join on the sentiments. So we basically create a tibble that contains all the words with their sentiments, like we did in the sentiment analysis part of this workshop. We're then going to count each word with the sentiment. Sorting equals true. So basically we're counting each sentiment, rather, putting it into a column called word. And then we're then going to pivot this wider to create that wide tibble where the sentiments are running as column names across the top. So the names will come from the sentiment. The values will come from the n column. And of course we'll fill missing columns with zeros. So this is exactly what we had before. And if I just show you the tibble at the end, when we run this, Sherlock sentiments should all be fine. There we are. Word, and then the various sentiments going across here. So time has anticipation 151 times, etc. Now that we've got this, where we said that for anticipation, time appears 151 times, found, joy appears 108 times, etc. What we can now do is we can draw specific word clouds for specific sentiments by picking out these specific columns. So for example, if I wanted to draw a word cloud of all the words associated with joy, I could pipe the Sherlock sentiments tibble through the word cloud function. But now instead of picking out the n column for the count, because we now have the count of the joy, number of times joy words appear, we can use the joy column. Again, we specify the min frequency, but now let's use a minimum frequency of say 10, because there are fewer joy words as opposed to looking at all of the words. Using random order equals false. And I'm going to here now use another color palette. So let's use brewer.pal. And this time we're going to do 8 colours from Pu'or, purple orange. So let's have a look and see what this gives us. There we are. So these are the joyful words, of which found was the most common, going back to shining feeling. And it's in a nice sort of purple orangey colour set. We could do something very similar for all of the fear words. So again, if we now take the fear words, so Sherlock sentiments, pipe that through with word cloud, and now taking instead of the n column or the joy column, we'll now take the fear column. Min frequency again, let's start with 10, and then we'll do random order equals false, and this time with the colours, let's basically pick up brewer.pal, 12 colours from the paired colour palette. I just chose these kind of because they were the ones that looked pretty or kind of gave me a look I wanted. So these are the most fearful words that appeared within the book. So okay, we've now run through word clouds. We've got an exercise at the bottom. Could you create some sentiment word clouds for your chosen book, exploring different sentiments? And then can you think about what are the advantages and disadvantages of these word clouds? And again, press pause, have a go yourself, and when you come back from pause, I'll show you the answer. Okay, you've now come back from pause, so let's have a go at the answer. So, again, I'm going to do this with the Hound book. So I've already now basically created my Hound Tibble, which we saw before. And indeed, actually, I'll do this from the beginning. So, sentiments, we must remember to get the sentiments from NRC. I'll re-download my Hound book. So this is from Gutenberg Download. And this is book number 2852. You, of course, will have a different number for your book. And then I'm going to tidy up my Hound book by basically passing this through unnest tokens, where we tokenize into the word column, tokenizing the text in the text column. And of course, we're going to anti-join with the stop words to make sure we get rid of those sort of scaffolding words. Now that we've got the tidy text into Hound, we will create Hound sentiments by taking Hound and then doing an inner join with the sentiments dictionary. Now that we've inner joined it with the sentiments dictionary, we want to create the count of each sentiment. It's just as we did in the sentiments chapter, and then we'll do the same thing, we'll pivot it wider so that then we create a wide tibble where the names of the columns come from the sentiment value, sentiment column, the values come from the n column, and we're going to fill any missing values with a 0. Finally, now that we have this rotated, this wider tibble, we can then do Hound sentiments, and we can pipe this through a word cloud looking for any of the sentiments that we're interested in. So in this case, I'm going to pick out maybe joy from the joy column. Min frequency equals 10. Random color, random order equals false. And then the colours, in this case, let's take the colours from brewer.pal, and I'm going to take 8 from the purple-orange set, just as we had before. Okay, if I now run this, there we are. So in terms of Hound of the Baskervilles, the joyful words are friend found, love white, food glad, green, surprise, etc. Now in terms of the question about the advantages and disadvantages of these things, so I mean I could, if I wanted to now bring up the, say, the fear cloud. Let's do fear. Hound sentiments, piping that through with word cloud, word, fear, fear, comma, min freak equals 10, then random color, random order equals false, colors equals brewer.pal, and we'll do 12 from the paired again. There we are. Always remember to make sure your little triple dots are right, left justified, as I have there. There are. So those are the joyful words. These are the sort of fearful words. And sort of the advantage and disadvantage of word clouds. You know, I think they're a nice kind of visualization. So when you sort of see them, they kind of give you a good view of what's there. So, you know, the most important words do sort of jump out. The disadvantage, though, is that short words, by definition, look smaller. So you can sort of feel sometimes that, you know, door, house, time matter. The longer words maybe grab your eyes a bit more. Also, you tend not to read words when they're rotated, so they sometimes kind of fall out of your eye. So I would say rather than being like a proper analytical tool, I think they're just kind of like a cute visualization that can be used effectively as a fun graphic rather than as something which really has sort of quantitative analytical sort of like meaning. But they look quite nice. I quite like them. So okay, that's brought us down to the end of this particular section. Thank you for going through it. I hope this was useful. And if it was, well, we have the next section waiting for you, and I look forward to seeing you there.